Hi students, this is a tutorial on how to use the VetSim Vet Simulator for Energy Skate Park. So first off, this is an HTML coded simulation, so you don't have to deal with any of the hazardous file, Java update, blah blah blah, but it's still a very powerful simulation, so you will find it valuable. Okay, I'm going to go through this a little quickly. So if you need to rewatch it, do so. But anyway, you're going to be looking at how energy changes happen when this skater is skating in different ways along these different ramps. And you're going to kind of be playing around with it and seeing how it happens on your own. I just want to make sure you understand how to use it. And I guess so that you could potentially use this video in case you can't access the simulator for some reason. But anyway, before you get started, make sure you have the pie chart clicked as well as the bar graph clicked. You need these in order to really see what is happening with energy at different parts along this person's journey, if you will. These two will help, but I won't necessarily ask any specific questions. They just may lead you to make some interesting observations, like about what her speed is. And I'm saying her because it does look like she has a ponytail. But what her speed is at different points along the track. And I think the grid helps you to just see that she does in fact return right up to about the same height without friction. And again, make sure you're on the intro, as I was at the beginning of this. Okay, so without further ado, I'm going to put her up at the top of one side of the ramp. Observe what happens. Also observe that this, oh, I just pointed with my finger, and obviously you can't see that. But observe how the bar on potential energy is, it changes height depending on where I start her at. I want you to notice that we have moved away from using the word potential energy and instead calling energy based on how far away from the surface of the earth you are, gravitational energy. Okay? So anyway, without further ado, bye! All right. I'm sure you are more than capable of making your own observations about energy changes throughout this girl's motion. You may change her mass to large or small to see how that happens. And you may change it to slow motion to more clearly see any changes that occur as she travels. Okay, so I'm going to restart her. Oh, no, I'm not. I'm going to reset the whole thing. Change the I'm not going to use this ramp. I think you have an idea of why. I'm going to use this ramp here just so you guys can see again exactly what can change. This is quite interesting too. Notice how the size of the graph changes depending on how far away from the surface of the earth the skater is. But we can go ahead and just reset her. Why don't we increase her mass? To play around with that a little bit more. And why don't we just put her up here and see what happens to her energy. Oh, sorry about that. I will not be re-recording because I don't feel like it. Okay, so there's that. Pause that. Go to friction. Again, check all this stuff. You can edit the friction here, edit the mass here. I'll go ahead and toss her on here, and you can see what happens because there has now been friction introduced into the system. And you can also see that her movement is much different now that friction has been introduced into the system. So that's how you use that feature. And then lastly, playground. This is quite interesting because you are able to build your own track. You can get as creative as you like. And I believe this allows you to stick her onto the other side of the, or maybe this is like a loop-de-loop feature. It sure looks like it. Yeah, it sure looks like that's how you do that. Alright, so let's see. Let's check this. Okay. Wow. That's kind of wacky. Okay, obviously this simulator is realistic in some respects and unrealistic in others. However, I think it's quite neat because it allows you to see what happens with energy in different circumstances. Alright, so obviously this track here probably makes no physical sense because she would most likely fall to the ground in many of these cases. But regardless, I think it's fun, and you should play around with it as your assignment tells you to. Alright, that's it. Bye.